Okay, fine. So we were doing the preparation of aldehydes and ketones. We did the part A, that is the method of preparation of aldehyde and ketones, and those method of preparation can be used for the preparation of both aldehydes and ketones. Now the second methods of preparation are for aldehydes only. In that we have done two name reactions and then using the D-bar H. Write the fourth one. This is another name reaction. Please write etard reaction. Please write with me. Alkyl benzenes can be oxidized to benzaldehyde. To benzaldehydes. With a solution of chromyl chloride in CCl4 or CS2. That means we need a non-polar solvent here. Right, next, a brown chromium complex is formed. A brown chromium complex is formed, which is decomposed by water to give benzaldehyde. Please write the reaction. This is toluene. Benzene ring attached to a methyl group. Chromyl chloride is CrO2Cl2. CrO2Cl2 in the presence of CS2, a non-polar solvent. It is going to give you a brown color complex. Which will be CH. And in the brackets, you are going to write OCrCl2. OH whole twice. In the presence of H3O plus, it is going to give you benzaldehyde. Okay, so that means toluene plus chromyl chloride, and in the second step, water. Okay, hydrolysis. This is toluene.
Excuse me, sir.
Tell me.
So which chapter is going on right now?
Is it SAF? SAF,
Yes.
it is aldehyde ketone. You were not present in the last lecture.
No.
You did not watch the lecture also.
No, sir. Just now, just today, my exam over.
Okay. This is aldehyde ketones and carboxylic acid.
Okay, sir.
Okay. Also write one more reaction. If we have a larger alkyl group here, For example, we have CH2, CH3, and we are using CrO2, Cl2. In the second step, we are using H3O plus. Then in this case, the CHO group will be on the last carbon. Okay, so the CH3 will be converted to, you'll have CH2 as it is, followed by CHO.
Sir, here if we use CS2 also, it will be same compound or different?
What? If you use?
CS2, sir, instead of H3O plus.
No. I mean, this is the second step. ना ये तो solvent है आपका, ठीक है? This is not a reactant. Please remember this. This is not a reactant. Okay. This is just a solvent. I'm saying in the second step H3O plus है ना?
Yes, sir.
Okay, so this is not a reagent. It is just a solvent. This is a solvent. Okay. Because if I also, and as you can see later we are going to use water. तो पहले ही पानी में क्यों नहीं solvent solution बनाया हमने? Because if I have chromium inside water which is slightly also acidic, it is going to convert it into what? A very strong oxidizing agent. And when it gets converted into a very strong oxidizing agent, I will not be getting benzaldehyde, rather I will be getting benzoic acid. It will like oxidize like furthermore. Okay, so we separate these steps. First we use a non-polar solvent, which is going to like slightly lower the reactivity of the chromium complex, and it is not going to get it converted to benzoic acid. Okay, and then in the second step, once we get this brown chromium complex, we separate it and then we add one. Please take a screenshot, guys, those who are late.
Sir, how much have you done until now?
This
Okay.
much only. Actually, moving on. Please write the next reaction. Using chromic oxide in acetic anhydride. Fifth. In acetic anhydride. Please write with me. treatment of alkyl benzene with chromic oxide in the presence of acetic anhydride gives aromatic aldehyde. Please write it. Here again, same thing. Benzene ring with a CH3 group. The reagent that we are going to use here, this is going to be CrO3. And here only we are going to use CH3CO whole twice O. What is this CH3CO whole twice O? This is double bond O, double bond O. Okay, this is acetic anhydride. Okay, and there is certain temperature that we have to maintain, that is 273 to 283 Kelvin. This is going to give you this is named as benzaldehyde diacetate. Benzaldehyde diacetate. And hydrolysis, it is going to give you benzaldehyde. Also, this diacetate, it converts itself to acetic acid. So you'll get 2 moles of CH3 COOH in the presence of an acid. Done, everyone? Yes or no? Please tell me.
Wait, sir.
Okay. Right, next. by side chain chlorination. This is sixth way. Again, we are starting with toluene, benzene ring with CH3. And first of all, we are doing free radical halogenation here. We have Cl2 in the presence of H nu. Okay, what it is going to do, we are going to substitute two hydrogens from here like this. First of all, we are going to get CHCl2. Now, when we have chlorines here, then we can add water, and then these chlorines will be replaced by OH negative. We'll get H2O at 373 Kelvin. From here, what is going to happen? The chlorines will be replaced by OH. So I will get carbon, one hydrogen, one OH, and another OH. Now, whenever we have gem diol type of situation, water molecule leaves, leading to formation of CHO group.
I say, what is gem diol?
Gem diol. When one carbon atom contains two OH group. If you remember the first class, in that class only I have told you guys that no. Is that part? See, gem diol means when you have carbon atom which has two OH groups attached to it. Okay, so that means it is gem diol. It starts from, I think the root word is Gemini. That's sun sign. Okay, so Gemini is like what, twins, I think, right? So you have two OH kind of twins, and di means two, ol means you have two OH in the same carbon atom. Okay, in the same carbon atom you have two OH. Similarly, you can have gem dichloride, gem dibromide. Okay, so these things are also there. Gem means in the same carbon atom you have two things: oxygen, hydroxide, and hydroxide groups.
Okay, so in that situation, water leaves.
In that situation, water leaves, and you get okay. So this double bond, yeah, it gets converted to double bond. This oxygen atom actually it attacks on this hydrogen. Okay, and this, since it is attacked by oxygen atom giving it electron, the hydrogen does not require this bond here, so it migrates, this bond migrates here, and since this carbon atom, it is going to give electrons to oxygen, and then you get water from here. So when you have gem diol type of situation, you get aldehyde. The seventh method of preparation by Gattermann-Koch reaction. In this reaction, we start with benzene. And with KO, you will remember CO in the presence of HCl. And we also use anhydrous AlCl3. And this gives you benzaldehyde. Is right. When benzene is treated with carbon monoxide, carbon monoxide and HCl in the presence of anhydrous AlCl3. Okay, this anhydrous AlCl3 is just a catalyst, and you can use some other Lewis acids such as cuprous chloride also, Cu2Cl2. Anhydrous AlCl3, it gives benzaldehyde. Write the C method of preparation of ketones only. Method of preparation of ketones only, you'll write the first reaction, that is from acyl chlorides. From acyl chlorides. Please write with me. When acyl chlorides are treated with dialkyl cadmium in the presence of dry ether, they form ketones. Right, another point, dialkyl cadmium is prepared by Grignard reagent and anhydrous cadmium chloride. So we start with some RMGX. We react this with cadmium chloride, CdCl2. This is dry, in the presence of dry ether. We don't need any water here, okay? Dry ether. Now, this chlorides will be replaced by the R groups. Okay, so you need two Grignard reagent and we are going to get CdR2. Okay, R twice plus 2 MgX and chloride will be there. Now, this CdR2 is reacted with acyl chloride. We have R. Let's put this R dash. C double bond O. Cl plus R2 CD. Now again, 2 moles of acyl chloride will also be used, and we are going to get R dash C double bond O R. This chloride is again replaced by this R group. 2 moles plus I'm going to get CdCl2. For a specific example, please see. I'm starting with CS3 MgBr plus CdCl2 in the presence of dry ether. This is going to give me CD CS3 whole twice. Okay, plus we are going to get 2 MgBr Cl. That's another thing, but we are going to get cadmium, and there is dimethyl cadmium we are going to get here. Now this dimethyl cadmium CD CS3 whole twice is being reacted with, let's suppose, 2 carbon atoms, double bond O, and we have here Cl. I will need 2 moles of this also. Now, what is going to happen? This part will be as it is. This part will be as it is, and the chloride ion will be replaced by CS3. So I'll get 2 moles of double bond as it is, and we are going to get CS3. Please see this CS3 here. This is coming from R2CD, and this R is coming from RMGX. Okay. Now, if you get some question like this, let's see. We have MgBr, and they have given you a sequence of steps. First step, they are saying that you have CdCl2, and the second step you are going to react whatever the product from the first step, you are going to react this with, let's suppose, CS3 C double bond O Cl. Okay. So here you are going to get a ketone. Now ketone will have this part CS3 C double bond O. Now the rest of the part is going to come from this Grignard reagent, CS3 CH2, CH2 and CS3. Okay, please remember this is from Grignard reagent, and this part is from acyl chloride. Please write this down, guys. Done, everyone. Yes or no? Please tell me.
Oh, wait, sir.
Write it fast, guys. Please write it quickly. Done, everyone?
The where's the last equation?
Okay. Right, next. From nitriles. Using Grignard reagent. You have seen this reaction in haloalkane haloarenes also in the conversion part. Please write both aliphatic and aromatic ketones. Both aliphatic and aromatic ketones can be prepared by treating an alkyl or aryl nitride with suitable Grignard reagent. Followed by hydrolysis. Okay, so if I have something like this, CH3CH2 MgBr plus CH3 C triple bond N. Now, first of all, you see what are the things here and how attacks takes place. This carbon atom, it is connected to nitrogen atom, which is more electronegative. That is why it is going to get delta negative charge. This carbon atom here, it is connected to Mg, which is a metal which has a tendency to lose electron. And since it is, this will be delta positive and this will be delta negative. This carbon is going to be delta positive because it is connected to electronegative element, which is pulling the electrons from the carbon atom. That is a delta positive. This carbon is getting electron from the magnesium atom. That is why it is delta negative. So this carbon atom is going to attack on this carbon atom. Okay. And it will lead to breaking of a pi bond like this. And we are going to get a compound like this. We have CH3 carbon, and then we are going to be having CH2 CH3. Please remember this CH2 CH3. Wait a second. We'll make this green. Okay, so this CH3 CH2, this is coming from the Grignard reagent. And then we have double bond N and MgBr. Now, when I'm going to do hydrolysis, I don't know how many of you guys remember, but we have done this type of reaction in haloalkane halorene conversion part. When we are going to do hydrolysis, then what is going to happen? You are going to get oxygen atom onto this carbon atom. This double bond will be replaced by oxygen, and this nitrogen is going to get the two hydrogens. Okay, so please see what is going to happen. You're going to get CH3C with a double bond O, CH2 CH3 plus you are going to get NH3 and you are going to get MgOHBr. Again, it is important to see that this part is from your Grignard reagent. Okay. And the carbon that is containing double bond O, that is coming from your nitride. So if I get this in red color, then I should write this also in red color. Okay. So these two are from your nitride, and the rest of the carbon atoms are from Grignard reagent. And if you have something like this, you see here we have 3 carbon atoms now. Okay. This is S3O plus yahan pe. Now what is going to happen? The first reaction is with CN, second reaction is with S3O plus. So first of all, you will get an addition product like this, and then you are going to get the benzene ring. Only this part is from your Grignard reagent. Then you have this carbon atom that is connected to nitrogen. It will get a double bond O. Then you have another carbon atom and one more carbon atom. Please write this down. Is everyone done? Yes or no? Please tell me.
No.
Write down fast. Write it fast, guys. Write the next one, third. This is Friedel-Crafts reaction. Friedel-Crafts acylation of benzene. Please write. aromatic ketones can be prepared by Friedel-Crafts acylation by treating aromatic hydrocarbon with acid chloride in the presence of anhydrous AlCl3. Okay, this is again a Lewis acid. So you can have benzene plus CS3 C double bond OCl in the presence of anhydrous AlCl3, and you are going to get C double bond O and then Cl. Sorry, C double bond O and then CS3. This Cl has been replaced by the benzene ring. Okay, Cl की जगह बस आपको क्या लिख देना, benzene लिख देना. So you can have something like this also. बहुत ही आसान है, सेम चीज लिखिए, डबल बॉन्ड O और Cl की जगह benzene ring. You can also have benzene ring plus C double bond Cl anhydrous AlCl3. You make the same thing, and जो अभी आपके पास acid chloride है, and instead of chlorine you're going to write benzene ring. Write it down fast.
Sir, quick question. The first one has ALCL3. The rest has ALCL3 or?
हाँ, ये वो comma is there, no?
Yeah, okay.
It means whatever is it.
Then, as I can see from the other ones, that the benzene ring replaces Cl.
Yep, in all the cases, no?
Yeah, but the first one, why is there a CH3?
अरे यार, what is this? वो बस हमने अगर इसका वो हम ऐसे लिख देते.
Oh, yeah, okay. I got confused. Okay.
Got it?
Yeah, thank you.
Then guys, yes or no, please tell me. Not done? Write it fast, guys. Sorry. See, for the first one, what class of compound is this? Is it carboxylic acid? Is it amine? Is it alcohol, aldehyde, ketone? What is this?
Alcohol.
Alcohol. And alcohol, we are converting alcohol to what? What class of compound is this?
The aldehyde.
Aldehyde.
Aldehyde. So what reagent should we use from alcohol to aldehyde? Tell me.
The PCC.
Very good. Second, again, what class of compound is this?
So alcohol,
Alcohol to
ketone. Again,
ketone. Again, PCC. शर्माने का नहीं है, ठीक है? Even if this question comes in exam and you are going to write two, I mean, ऐसा नहीं मत सोचिएगा कि हमको अलग अलग ही reagents लिखने हैं, ठीक है? बहुत ज्यादा reagent याद करना, like उसको दिमाग में रखना उतना ज्यादा अच्छा नहीं है आपके लिए, okay? So you write PCC twice also, there is no problem in that. I mean, चलिए फिर वो कभी और बताएंगे आपको, अभी यहाँ पे देखें. What about this one? Chlorotoluene.
The alkyl benzene to aldehyde.
So what are we going to use in the third case?
Sir,
We did today.
yes, sir, we did today. Let me check.
Alkyl benzene to aldehyde. Please check other guys also.
Sir, chromium oxide. Sorry, yeah, chromium oxide.
And do we use anything with that?
The chromium complex.
No. We use something with that, no? We use chromic oxide and what?
The CH3CO.
Acetic anhydride. Okay. An easier example to do this one will be, yeah, you can use that also. So you can either use chromyl chloride and then hydrolysis, okay, or you can use what? CrO3 in the presence of acetic acid. Now please remember what they are asking. Give the names of reagent. ठीक है? क्या बोला उन्होंने? Names of reagent. So you don't need to write the structures of hexane 1 to hexanal. Okay? ठीक है, जबरदस्ती का ज्यादा काम करके ना, अगर हेक्सेन 1 का किसी ने स्ट्रक्चर गलत लिख दिया, फिर मार्क्स वहां पे काट देगा टीचर. If they are asking you to give the names of the reagent, just give the name of the reagent and done with it. Okay, don't try to write now. That's why I'm saying that what is the class of these compounds. I'm not even bothered about the structure right now. Okay, for the third one, what we are going to use? We are going to use CrO3. अब आपको वो समझ में नहीं आ रहा है ना कि CH3CO होल्ड पर इसमें O क्या है, तो प्लीज याद रख लीजिए एसिटिक एनहाइड्राइड. Okay, CrO3 in the presence of acetic anhydride. Fourth one, you have ethane nitride to ethanol. So from nitride
To aldehyde.
to aldehyde, क्या यूज करेंगे बताइए?
The Grignard reagent.
बस Grignard reagent
And hydrolysis.
and hydrolysis. What else? Anything else that we can use? Grignard reagent तो आपको फिर ना वहां पे बताना पड़ेगा कि कौन सा Grignard reagent. See, this is also a Grignard reagent. This is also a Grignard reagent. Okay, so please don't say Grignard reagent. You have to specify what Grignard reagent.
For that, we have to draw the structure.
We have no, you don't have to draw the structure of anything. Nitrile to aldehyde. I mean, see, the number of carbon is same in both the cases, right? Ethane nitrile and ethanol. There is a name reaction for this, nitrile to aldehyde. There is a name reaction for this, ना? आप ही पूछ रहे थे सर इसको कैसे याद करना चाहिए?
The Stephan reaction.
Stephan reaction, right? So what do we use in Stephan reaction?
Stannous
Minashi,
chloride.
that is also stannous chloride. Or you can also use SnCl2. You can use SnCl2. That is followed by, this is the first step. In the second step, you are going to do H3O plus. Or you can use what? Dibal H also. Diisobutyl aluminium hydride. Okay. What about this allyl alcohol to propanol? So we are going from we are going from alcohol to aldehyde.
So again,
What should
PCC.
we use? हाँ, यहाँ पे देखिए PCC ही use कर सकते हैं और कुछ मत use कीजिएगा. क्यों? What is allyl alcohol? Allyl alcohol is going to have a double bond. ठीक है? Allyl alcohol is going to have a double bond. The structure is going to be something like this: 1, 2, 3, and then you have OH. This is allyl alcohol. You don't want to disturb this double bond. That is why we are always going to use for this one, especially. Fifth one is going to be PCC. ठीक है? PCC लिख दीजिएगा. पूरा full name लिखने की जरूरत नहीं है यहाँ पे. ठीक?
We
What
always
about
go
this?
with- So can we always go with PCC in the conversion?
अरे, yeah, you can always go with PCC. ठीक है? It's your safest bet. What about this one? This is what? Alkene to aldehyde. What are we going to use? This is one of the important reaction, and we have seen this reaction in your 11th standard also. जिसमें घर बनता है ऐसे. कौन सा reaction जिसमें घर बनता है?
Ozonolysis.
Correct. So what are we going to use here? We are going to use O3 in the presence of. Then next step is going to be zinc dust and H2O and hydrolysis, right? All if you got this, how to do these type of questions. Whenever you are being asked now, give the name of reagents, then please only think about giving the name of reagent. Don't worry about the structures that time. Okay. Write this down, guys.
Sir, can you zoom out?
For the questions.
Yes.
This is an NCERT. You can copy the question later on also.
Done, sir.
Anyone still writing?
Sir, I'm writing. Wait.
I'll write it fast. Done, guys. Done, everyone.
Done, sir.
Right, next. Physical properties of aldehydes and ketones. First of all, write solubility. The solubility you will write aldehydes and ketones. Aldehydes and ketones are miscible in as the oxygen of aldehyde and ketones form hydrogen bonds with hydrogen of H2O. Okay, so both the aldehydes and ketones, they have C double bond O, right? C double bond O, you will have some groups here. Water is two hydrogen atoms attached to oxygen. And this hydrogen is going to have delta positive, and then this oxygen is going to have a hydrogen bond with this hydrogen. Similarly, you can have some hydrogen bond with other molecule also. Okay, so like this, they have hydrogen bond. That is why these are miscible in water. But please write, as you can see, that only this fragment here is favorable for this fragment here is favorable for what? Favorable for solubility. And as you are going to increase the number of carbon atoms, those are non-polar, they are not favorable for solubility. And if you are going to increase the number of carbon atoms in aldehydes and ketones, that will decrease the solubility very rapidly. Right, the next point. Solubility of aldehydes and ketones decreases rapidly with increase in the length of alkyl chain. Right, next. Regarding boiling points, please write the boiling point of aldehydes and ketones are higher than non-polar hydrocarbons and weakly polar ethers. However, due to the absence of hydrogen bond within aldehyde and ketones, their boiling point is lower than corresponding alcohols. Done, everyone? Yes or no? Please tell me.
1 minute, sir. Last line.
See, this is aldehyde. A, B, C, and D. B structure is alcohol, C structure is ether, and the D structure is alkane. Okay, so aldehyde is going to be polar. This is hydrogen bond. This is weakly polar. And this is non-polar. So tell me, guys, which is the strongest intermolecular force of attraction here? Which is the
H bond.
strongest H bond? So B will be having the highest boiling point, followed by
Polar.
polar. That's going to give you A, followed by weakly polar, that is C, and then you will have D. Write a note. Is right here. Ketones have slightly more boiling point than isomeric aldehydes. Right, comma and next. This is because of the presence of two electron releasing groups around carbonyl carbon. Ketones. All of you wrote this note? Yes or no, please tell me.
No, sir.
Please write it fast. अरे isomeric aldehyde
Yes,
का
sir,
मतलब
done.
होता है.
Done, sir.
Okay. Umar, isomeric aldehyde means if you have 3 carbon atoms and a ketone like this, and you have for this isomeric aldehyde will be 1, 2, 3 carbon atoms like this. So the boiling point of ketone is going to be higher in this case. Okay, so you have 3 carbon atoms in the ketone. Here also you have 3 carbon atoms. As you will see, the formula for both of these is going to be same. Structure is different here, but the formula is going to be same. Isomeric aldehyde is not a particular aldehyde. वो हर एक कीटोन के लिए अलग अलग होगा. Right, next. Chemical properties of aldehydes and ketones. Now, both aldehydes and ketone, they will undergo some very characteristic reactions due to the presence of carbonyl.
Sir, can you scroll up a little bit, please?
Since you have C double bond O like
Yes,
this.
sir, done.
Okay. Now this C double bond O, this is going to be delta positive. This is going to be delta negative. If it is delta positive, it is what? It can be attacked by nucleophile. It can be attacked by nucleophile. If it will be attacked by nucleophile, this bond will break like this, and you are going to get carbon, some nucleophile added here, and then you are going to get O negative. To remove this O negative, generally what we do is, generally we add either H plus atom there, so you're going to get OH group there, or sometimes what happens, it automatically releases some groups. Okay, so you will get O negative here, and then in the presence of H plus, you are going to get nucleophile carbon and then OH. Okay, this type of reaction, these are known as nucleophilic addition reaction. But before going to the nucleophilic addition reaction and the mechanism, let's practice a few reactions. तो फिर आपका हाथ चालू हो जाएगा. Okay, please write with me. The first reaction. Addition of ammonia and ammonia derivatives. Ammonia and ammonia derivatives. See, you will have aldehyde or ketone. All the aldehydes and ketones, they have C double bond O. Then there will be ammonia or ammonia derivative. Let's start with ammonia. If you have simple ammonia, that is NH3. In this NH3, as you can see, what is going to happen? This carbon is delta positive, and this nitrogen is having lone pair electron. So this nitrogen can easily attack on this carbon atom of carbonyl compound. As soon as it will attack, this pi bond is going to break, and you are going to get a product something like this. This Nitrogen will be here. You will have O negative, right? Now you have nitrogen with 3 hydrogens. Nitrogen will get a positive charge because it is donating electrons. Nitrogen is what? Positively charged. It is electronegative element. Hydrogen will be giving its electron, right? Nitrogen will be pulling electrons from the hydrogen atom because it is positively charged and also electronegative element. This is going to make this hydrogen very, very, very delta positive. As soon as it will get delta positive, this oxygen atom will attack onto this hydrogen atom and it will abstract the hydrogen, giving you this product. Carbon with the 2 groups as it is, with NH2 here, and you are going to get OH. Any problem till here? This one, please tell me, guys.
No, sir.
No problem till here. Now see, now the oxygen atom is not going to stop till now. Oxygen, it has the lone pair electrons. This nitrogen also has few more hydrogens. Okay, now this oxygen is going to again take a hydrogen. This is going to give you carbon, single bond NH. OH2 positive. Now you can easily see that you have here H2O, right? And as soon as it is going to give this electron to hydrogen atom, this hydrogen atom is going to give electrons to this pi bond. So it will be double bond here, and this electron will be given to H2O. So you will be getting 2 products: carbon, double bond NH plus H2O. ठीक है? ये water, this water is very important here. These 2 hydrogens are coming from what part? Tell me. These 2 hydrogens are coming from
Oxygen.
no, अरे oxygens तो यहाँ आ रहा है. Hydrogen कहाँ से आ रहा है? You have 2 reactants. You have the carbon
Ammonia.
aldehyde और हाँ, ammonia से आ रहा है. This is from NH3. And this oxygen is from
Carbon.
this oxygen, carbon, this carbonyl compound. Okay, aldehyde or ketone. Okay, now in general, if you have any carbonyl compound, plus you just require 1 hydrogen and nitrogen. You require anything, some substituent Z, and you have NH2. ठीक है? तो क्या होगा? What is going to happen? You are going to get carbon, double bond NZ plus H2O. Is this clear? Yes or no? Please tell me, guys.
What is that, sir?
Any other substituent. If you have anything attached with nitrogen here, okay, so this will combine and you are going to get NZ. We will see what is Z. Z can be anything. You can have like this also, no? H2N and then alkyl group. Can you see that? You can also have H2N and then can be OH group. There can be many substituent in place of this Z. Okay, this general scheme of reaction is going to be like this. But first of all, you write the above part. Whatever is happening, you should understand that. And then also you can generalize with a particular product. Whenever a hydrogen atom is transformed, it is transferred from one atom to other atom, it is known as proton transfer. And proton transfer is one of the most important step in organic chemistry. If you get stuck in organic chemistry in any one of the mechanistic step, then always try for a proton transfer.
So can you repeat?
If you get stuck in any of the mechanistic step, always try to do a proton transfer.
Like
Then
what-
maybe you can get.
what
What is proton? Proton transfer. This is proton transfer. This step. Oxygen atom is just taking the proton of nitrogen atom. So proton is transferring from nitrogen to oxygen. So the proton transfer is generally between 2 electronegative elements. ठीक है, कभी कभी आपके पास फॉर एग्जांपल कार्बन is having some lone pair electron, and then you have another carbon with OH like this, so this carbon can attack here and can take the proton. Then guys, yes or no? No, Amar, you try to understand yourself ना, आप नहीं थे क्या क्लास में? अभी तो हम समझाए. Which step you are having problem with? Tell me. Listen here, this carbon atom is having delta positive charge because it is connected to electronegative oxygen atom. This nitrogen atom with its lone pair attacks on this carbon atom. As soon as it attacks, carbon cannot form pi bond. That is why it breaks this pi bond with oxygen atom, leading to formation of a carbon single bond O negative, and then nitrogen attaches onto the carbonyl carbon. Nitrogen still has 3 hydrogen atoms, and it has a 4th bond giving its electron. That is why a positive charge. Now, since it is having a positive charge, it is also an electronegative element. This hydrogens, whatever is attached with nitrogen, is going to get a very high delta positive charge. This will lead to the attack of O negative towards this hydrogen atom. There will be first proton transfer. Then next, what is going to happen? Still, this nitrogen atom is connected with hydrogen. This oxygen atom is again going to attack on this hydrogen. Now, this NH bond, it is going to give the electrons towards this CN and making it double bond. So you are going to get carbon double bond NH, and then you are going to get O, which is bonded to 2 hydrogen atom, giving it a positive charge. As soon as it gets positive charge, it will break the bond with carbon atom, and it is going to leave as water. And you are going to get carbon with the 2 groups attached as it is, and then double bond NH. Done, everyone?
Yes, sir.
Now, please see. I'm giving a very simple task initially, okay? Question is to identify. We have seen that what is happening. एक बार फिर से देख लीजिए क्या हो रहा है. You have carbon double bond O plus you have H2N, and there will be Z attached to it. That means anything other than NH2 is going to be the Z, okay? It is going to give you carbon double bond NZ. You have to do what? You have to identify the Z. फर्स्ट केस में आप बताइए, इफ यू हैव NH3, then what is the Z? What is the Z in this case? What is other than nitrogen and 2 hydrogens? What is other than nitrogen and 2 hydrogens?
Hydrogen.
अरे नाइट्रोजन एंड 2 हाइड्रोजन के अलावा क्या है पूछ रहे भाई? Z में Z. What is the Z?
Sir, hydrogen.
Any substituent.
अरे एनी सब्स्टिट्यूएंट नहीं है यहाँ पे इस केस में.
Sir,
In this case,
hydrogen.
you tell. In this
Hydrogen.
case, I need answers from others also. In this case, what is the Z? What is the substituent other than nitrogen and 2 hydrogens?
Sir, hydrogen.
Can all of you see that? Yes or no? Please tell me. Saif, Minashi, Khalid, Hishma. Can all of you see that? Yes or no? Hishma, can you see what is the Z here?
Yes, sir.
What is the Z here?
Hydrogen.
Saif, can you see the Z here? What is the Z here? Saif,
Yes,
can you
sir.
see? दिख रहा है कि नहीं दिख रहा है? अगर किसी ने झूठ मूठ का बोला ना दिख रहा है, पता चल जाएगा हमको थोड़ी देर में. You have H2, nitrogen and another hydrogen here. That is why it is NH3. ठीक है, तो इस फॉर्मेट में सोचने की कोशिश कीजिए. Your what is the hydrogen Z here? The Z is hydrogen here. Right, the second one. What is the Z here?
OH.
What is the Z here?
NH2.
What is the Z here?
NH2 with benzene.
NH2 नहीं, NH with benzene. Can all of you see this now? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Okay. Now we can do some problems. Okay. लिखने की जरूरत नहीं है इसको. If you can identify what is the Z, that's fine. Write the first one.
Yeah, sir, can you scroll up for a second?
Yeah, sure.
Done, sir.
ठीक है, please see what is going to happen. If you have CS3, CHO, CS3, CHO. Let's write starting with NH3. What is the product that you are going to get here? यहाँ से देखिए, अब हमेशा आपको ना इस तरह से नहीं दिखेगा. You'll not be given in this manner all the questions. You have to think and you have to picture it in your head like that. So you have what we will picture here. This is C double bond O, right? C double bond O gets away. You have CS3. You have carbon with a double bond nitrogen and 1 hydrogen, and the H is already here as it is. Okay? You have to picture things in your head only. If you have something like this, plus NH3, then double bond N and 1 H hydrogen only. Right, next, if you have something like this, CS3, CHO plus NH3O, sorry, NH2OH, then you have CS3, this carbon with the hydrogen as it is, the double bond with oxygen is being replaced by nitrogen and OH. ठीक है, ये H2 जाएगा कहाँ? पानी लेने. ठीक है, it will get converted to water. Remember these things. समझ में आ रहा है नहीं आ रहा है? Tell me guys. Hishma, Khalid, Minashi. Can all of you see this product?
Yes,
Yes
sir.
or no? Similarly, if you have double bond O, NH2, NH, CO, NH2. Okay, this is known as semi-carbazide. This is going to give you what? यहाँ से this H2 will be forming water and you will be having double bond N followed by again an N. This is already having an H. You have C double bond O and then NH2. C double bond O followed by NH2. You can also write the structure as N N NHCONH2. This is known as semicarbazone.
Sir, what is the spelling, sir?
वो सारी चीजें लिखाएंगे हम, ठीक है ना, ये सारे रिएक्शन को ऐसे नहीं छोड़ेंगे. We'll write each and every reaction with ammonia, with hydroxylamine, with semicarbazide forming semicarbazone. Okay, but right now I just want you guys to know the reactions. If you have something like this, plus let us suppose you have NH2, NH followed by benzene, right? Then what is the product going to be? यहाँ पे आप लोग बस ऐसे दिया हुआ, लेकिन you don't have to write everything like this ना, आप उसको इस तरह से कर लीजिए. Now you are going to write nitrogen followed by NH like this. Okay, you should be able to play with the structures. Write this down. You should have an analogy of organic chemistry as you have big Lego blocks, and then you break those Lego blocks to make new things. Okay, so like you should understand what part is coming from what of the reactants. Whenever you do a reaction, please think on those terms. That will train your mind. Done, everyone? हाँ guys, done? Not done. Can you repeat what I said, Muhammad Umar? Muhammad Umar, can you repeat what I said? Yep. That's what I was saying here, no? That's what I was trying to explain here. If you see, where is this hydrogen coming from? So what we are doing, we are breaking this carbonyl and ammonia, right? We're breaking this carbonyl ammonia and we are forming some derivatives and a water molecule. From this, with this water molecule, hydrogen is coming from ammonia, oxygen is coming from a different Lego block, and we are forming a different Lego block, that is new Lego block, that has water here. I was saying just that, nothing else. Done, everyone? Is there anyone who's still writing? Anyone who is still writing? Done. Okay, that's it for today, guys. Please practice the preparation of alcohols. Okay, sorry, preparation of aldehyde and ketones. And we'll start with the chemical properties properly in the next class. Now you have an idea what type of reaction takes place, how the attacks happen in the carbonyl carbon. Okay, and we will see some more addition reaction in the next class. So thank you, guys. Thank you very much. Bye bye. Take care, guys.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you. Thank you.
Sir,
How, tell me?
sir, can you explain the ozonolysis of alkenes reaction?
What you did not understand?